from your perspective, that this decision that I have made, maybe you manage a pharmacy, that if you work in core pharmacy, how do you use data at work? So I'm going to chill on that, and I'm waiting for answers on that. So I'll be reading them out. So the question is, as pharmacists, how do you use data at work, or how do you use data in school? How do you use, okay, it's either for pharmacists, it's either you're kind of still in school or in service. So how do you use data? Or maybe I should have asked first, do you use data at all? Not internet call credit. So I'm waiting. The last answer came in, yes. Okay, Abubakar Sadiq says stock taking, forecasting, patient counseling, journal publication. Those are some of the ways he uses data. Okay, I'm looking forward to other responses. Sorry, I have to check this. Okay, the question is, how do you use data at work? We have an answer: stock taking, forecasting, patient counseling, journal publication. So I have 4 points from there. Who else uses data at work? Not internet credit, but data. Jimmy, what kind of performance have you used data to improve? Ibrahim Abubakar says is presently making policies in the place where he works. They would like to start a pharmacy technician school because of the rate at which they send other their personnel. Okay, they think it's better to have their own school. Cool. The coordinator says sales pattern, drug utilization pattern. Okay. Drug purchasing. Festus, how do you use it in drug purchasing? If you can explain more, it would be nice. And then I can go to the next question. Okay, Festus, I was thinking that you give a bit of an explanation of drug purchasing. If you have more to share, it's okay if you don't have more to share for now. And the next question is, okay, market intelligence. Yimika says market intelligence for pharmaceutical coils, how their brands are performing in the market and the different sales drivers. Cool. So the next question is, do you think you are competent at using data to make decision? Do you think you're competent? Let's do it like this. Let's make this a score. Let's make it between 0 and 5. So 0 is you do not have any competence at all. 5 is you do think you're competent at data. So let's use that scale. Please, you can answer that in the chat window. Do you think you're competent at using data? Let's grade it between 0 and 5. Okay, Emeka says 3. Ibrahim says 4. The coordinator says 3. Ortega says 4. Okay. Abubakar says 3. Festo says 3. Okay. I don't know if there will be other responses. Zainab, where are you? I've not seen your response. At least I know. Okay. Emmanuel says 3. Zainab says 3. Okay, let's see. Is there another person that wants to answer before we go to the last question? Jimmy says 4. Okay, cool. Okay, so in the chat window again, what are your most important data tools? Like, we have established the fact that, okay, people have shared how they use data at work. The team that we are currently discussing with, they have shared that what they think their competence level is on a scale of 0 to 5. So Now, what are your most important data tools? Daniel says 3. I don't think I've read Daniel's response. So what are your most important data tools? You know, when you're working with data at work, what are your most important tools that you use, you know, to analyze data, you know, to whatever extent that you can do it? Do you do it from memory? Do you just look at it that, do you do it on intuition? You know, intuition could be a tool. People's feedback. Abubakar says people's feedback. I'm asking for both, let me say, philosophical answers and actual tool answers. Okay, Abubakar and Zainab, they said SPSS. Okay, that's a data tool. Okay, I'm waiting for others. I'm just trying to, the goal of MS Excel, Ishaya Abubakar. Jimmy uses Power BI, data, and Excel, Intuition, and Excel. Sometimes Minitab. Zainab said that, Excel. Good. Okay, good. Okay, so Yimika uses Power BI and ML Excel. Obia Emmanuel uses R. Okay. Okay, so we've gone through those questions together, and the purpose of this page is that we establish that everyone uses data, at least in our discussion. And the use of data is not limited to how educated someone is. People have intuition, people have experiences. I don't know, like in pharmacognosy class, it's how some cultures, maybe in Yoruba culture, they learn that they don't eat this kind of food in your family. It's based on data, of a food allergy. They just say it's an AWOL. It's not those that decision wasn't made by, it's not made by people who can read and write. I saw something about prediction of rainfall. Many times farmers are right about prediction of rainfalls. It's just that now there's global warming and all that, and some of it are scattered, but many times they are right. If you're interfacing with clients, there are things that the mother is sharing. There are those information that they share. Oh, if you do it like this, it may not always be correct, but some of those decisions, in fact, many of them, they are based on data. So the purpose of that question is to establish the fact that people use data, and people shared how they use data at work. You should use data at work. The purpose of the third question is to, like I said at the beginning, as pharmacists, I don't want data, I don't want it to be something scary to you. It's already in what you do. It's not like, I don't want you to see it as something that is out there that maybe, maybe some extremely brilliant people are the only people that work with data. You already work with data. It may not have been called that, but it's one of the things that we were trained as pharmacists to do well. It's one of those things that you do well already by making it out of pharmacy school. And do you think you're competent at using data? This is where maybe many people, you can learn more. I like the fact that people mentioned Excel as data. Excel is a powerful tool. But when I'm going to take question 4 and 5 together. What are your most important data tools? When people mention data analysis, data analytics, I think many people think of the biggest tools, but I can tell you Excel is just a type of spreadsheet. There are other spreadsheets. There is G Sheet, and there is that. But your most important, when I at work, when I make a selection of tools to use, tools are just tools. I could decide to use Python, I could decide to use something faster. The most important thing is always the question that I'm trying to answer. So this is where understanding fundamentals come in. Understanding fundamental, it's just like choosing drugs. You know that there are different classes of antibiotics. If you have established that this is an infection, of course, there are different factors that makes, that helps you to choose the right tool. But the key is to understand that whatever scenario that you are looking at, it is this, it's a bacterial infection. That's the first thing. And then you can start answering your questions from which of the tools should I deploy? The patient is poor. Definitely, I don't want to consider Rocephin. And then that's how it goes. So what I would like to share with pharmacists, share with, whoever is there, you may not be a pharmacist, this is a pharmacist thing, is that your job is not to be afraid of, a particular tool. Your job is not to be afraid of, oh, it's coding. It's just like a language. So your most important decision every time you have to work with data is always, what question am I trying to answer? And then you can consider different types of tools. And then it demystifies tools to you. Let's say in Excel, I already know how to maybe remove the ending of strings. The most important skill is to even know what a string is. And then I can easily type on the internet, the name in Excel, you know what it does. Maybe you expand a column in Excel, you know how to do that. You can always easily type how to expand a column with Python. The problem is the same thing. Your tool is just changing. Oh, you can do this in XPSS. You want to try it with Excel. It's easy for you to type that function and say how to do this in Excel. So your focus every time you're making decision. Okay, Jubril is raising his hand. Jubril, please, can you put your question in the chat window? I think that, yeah. So if you have questions, please put it in the chat window. So the goal of, as an analyst, as a pharmacist who is an analyst in this sense, trying to make sense of data, your goal is always to figure out the most important question, and you figure out that the tools are not the most difficult. It's easy for you to say, oh, I want to find mean of 10,000 rows of data in Excel. If you type that in online, you are going to find the answer. Someone will put something similar there, and then you can start from there. So your first job is to know what kind of questions you want to answer. I ask people this a lot. Sometimes I don't get answers back. So these are some questions to lay a foundation about what data science and data analytics is. I'm trying to move to the next page. Okay, so what is data? You can, I don't know what this red line is doing. Is it me? Okay, so what is data? It's what it is. A perspective that, okay, I can explain more about this later, but this was the more encompassing part, because some people spoke about data as if it's just numbers. It's tempting to think of data as if it's just numbers, but it's much more than that. It's not just numbers. So I liked this definition. I saw it online. Any observation collected in respect of any characteristic or event is called data. The question is not if the inference from the data is correct or is correct. Your data can have K-leg, and it can have issues, but it's still data. It may not be dirty data. It may be not useful data. Yes, so I saw this online, and it talks about a day in data. This was done in 2019. It's old data. That means more have been done. I included the link. Let me see if we can click on the link and give a better view. But the purpose of this infographics is to, okay, I left it opened. Let me see. Is it here? Yes. So to give a better view of what data is and how much data is being generated all over the world, let me see if I can put the link. Let me put the link in the chat window. So the authors of these infographics, they attempted to share what data is. You may have a better view, so I'll put the link in the chat window. The authors of this visualization, what they attempted to do is to talk about, online data that is generated daily, to give a perspective on I don't want this screen. Okay. So what they attempted to do is, sorry, my phone. Okay, so what they attempted to do is to talk about data that is generated per day to give a view of what exactly is happening. So this is a day in data. As at 2019, this is much more now. So there's a table here talking about data units. Some of them I've not used before. Some of them I can pronounce well. But up to as of 2019, up to 500 million tweets were tweeted per day. About 4 petabytes of data, is created by Facebook per day. About 350 million pictures, about 100 minutes or 350 million pictures, 100 million hours of videos and watch time. 294 billion emails are sent per day. The one you do at work where you and your colleague, you are trying to keep track of a matter, you're part of that statistics. And okay, so you can look at the statistics, but what they did is that this is the sheer amount of data that is generated per day. And because we're trying to establish why we should care about data and why it's your business, why you may not just want to say, oh, I'm a pharmacist, it's not really my business. So this is an idea of the kind of data that is generated per day. And this is digital data. That means that this is the one that they saw online on the internet. There's still so much more that is not being captured. And it's definitely much more than this. Okay, I copied this from Wikipedia, but it does a good job explaining what data science is. Please, can you hear me clearly? I'm just doing a mic check.
Yes, we can hear you.
Okay, thank you. Okay, so the definition of data science here is it's an interdisciplinary field. It uses scientific method, processes, algorithms, and systems to extract knowledge and insight from structured and unstructured data. It also helps you to apply knowledge and actionable insights from data across board of applications and domain. Data science is related to data mining, machine learning, big data, AI, and all that. So what data science really encompasses, as a pharmacist, this will not be difficult for you to grasp. It's just the same way in pharmacy school, different from pharmacognosy. It's different from I've forgotten this tech course, but I know you know it.
Pharmaceutical chemistry.
So it's just pharmaceutical chemistry, pharmaceutical technology. There are but pharmacy brought them together. Data science has exactly that vibe. It brings together statistics, informatics. This is where your coding comes in, data analysis. It brings about different components of David is raising his hand. David, please, can you ask your question in the chat window? Please, if you have questions, it can be in the chat window. So I'm trying to bring it home to pharmacy. So I know some people are saying, okay, I want to learn about data science. And the first time they're hearing, oh, you have to learn some coding, you have to learn about statistics, data visualization. They say, oh, it's too much. But I don't think pharmacists should say it's too much, because you're already coming from too much. You've already been there, done that kind of too much. So if it's something you're interested in, but it's a mix like that. I think that's that's a way to bring it home. It's a mix like that. It's a bit of different fields. And like we established, people have used data before we were born, even people that are not literate, people that do not have the same access to information as we do. Decision. They have extracted actionable insights from data. That's how we discovered it's from data. The mix. I think that's a summary that I sorry, my internet went off. So let me try again. Okay. Okay, so in the context of data science, there are, these are the type of data classification you have in your mind. You know, there are sub-classification, there is quantitative data, there is data, context of the data analyzed by putting in rows and column. And that's a lot of data that many people come across, the ones you put in your spreadsheets, the one you probably use for your fasting, the numbers that are in rows and columns, that row and column. This is probably what you have exposure to right now. It's mostly structured. This is what from the data being observable. So it's mostly structured data that we come to. But from the analysis that we did, you know, the infographics of the data that is generated per day are not structured data. So, you know, there are many data that we come across in pharmacy that are not, you know, they are not sales data. Sales data is structured data. You can put it in rows and columns. Structured data that you have access to is probably just 20% of the total data generated. And then we have the unstructured data. And this is where, if you're wondering what's the big deal about machine learning and AI, this is where they shine. At work, when I said that I work mostly with unstructured data, there's a part of artificial intelligence called natural language processing. This is mostly how you make computer, you know, understand natural language process. So your data comes in. I do a lot of work with unstructured data, text data, you know, image data that are not numbers and rows and columns, but it's about 80% of the data that is being generated. So if you will have an edge, if you will be an analyst of that, but I think as pharmacists, you do well with, you know, being great at structured data. Actually, if the purpose of learning analysis is just to support your work, make better forecasts, make better things, you'll be fine. And there's a lot to, to learn there. You know, they are valuable skills. People that are great with Excel, you know, people that do advanced Excel, you know, that automate simple processes. Many of the biggest companies in the world run on Excel, and, you know, they work well. Spreadsheets, not Excel. I'm trying not to be brand specific. So, and then there is semi-structured data, which is a mix of structured and unstructured data. You mostly get this, let's say I'm scraping the web and data comes back as JSON or XML file formats. But when you think about data science, I want you to see your data, you know, I would like you to see it, you know, in these three classes. Is that your data is structured, easily put into rows and columns. You can easily query it in a database. You know, that's straightforward and is the data that most people will work with, and that's okay. Okay, I'm trying to go to the next page. Let me see if it's still present. Okay. So let me see if we have questions. So do we have questions about what I've asked so far? Is there anything that seemed complicated that you think I should talk more on? The chat window is open. Let me try to make it smaller. So do you have questions about, questions about what is all this that they talk about AI. Is it real? The robots will take over the world. I'm sure you've been reading that AI will take over. Are you afraid that AI will take your job as a pharmacist? So I'm open to those kind of questions. So what is the first about data science, analytics, and AI? At the beginning of the session, we established the fact that data is as old as people. You don't need to be literate to make decisions with data. There are many that we just make based on intuition, and it doesn't make them incorrect. What really changed, that everybody is talking about the fourth industrial revolution and what AI will do. What really changed is data availability. About let's say 10 years ago, some people even in this meeting were not online. They were not wishing their friends happy birthday online. They were not sending emails. Some people probably just started sending emails when they graduated. I wasn't sending emails in school. I don't know if people now submit their assignments by email. So data availability and storage. Because of the advent of cloud computing, that you don't need to set up your own servers. And in fact, many free storage platforms, most of my data that is stored on Google Drive is free. There's more digital data available to analyze. That means that there's more data to, I'm going to give an instance of data availability as it relates to pharmacy here. We have a project where we are trying to extract side effect of medication that people talk about on social media. Those information that they don't give you willingly, some people don't even know they should report. But if you get to some discussion forum, people mention that I took this drug, it almost scattered my life. Because of AI, geospatial, we proposed that in one of our recent research that, as support to some of the things that, NAFDAC can do on pharmacovigilance. I'm bringing that home because this is a pharmacy thing. So, we were proposing that people talk about some of the side effects. You can use AI, you can use named entity recognition method to extract drug names surrounding, you can make graphs from it. A particular brand name, did the client mention some side effect in the context of that statement? Is it associated with it and things like that? It's a whole lot of research. It's one of the ways you use AI. It's data availability. People have always complained about medications that did not do well, but they probably did not have the platform to write it online. So the information sort of dies with whatever is in their sphere. It's what they report to you that you know. So because of data availability, there's more data and cheaper computation. There are some computation that I do at work. Let's say, I was working on some, text generation related to prescription. It takes quite a lot of computation. I was using GPU access, on the back end. Those kind of things, typically people like me all over the world, if it's not a big lab in Stafford, you don't have an opportunity to run your computation on those things. It's so before it used to be either you buy your own very big machine or you are restricted because of where you are. But because there's cheaper computation, I could buy some cloud computing unit, I'll run it on GPU on Google's computer or something, and I'll be fine. So it's one of the ways that it's why there's more analysis. So there's more digital data. People are giving logs of their lives, of whatever they are facing. They are sharing those information willingly. It's available online. And then easier implementation of AI techniques. For people, well, I'm not sure, it's more of AI techniques. Machine learning is an AI technique. I'll say easier implementation because if you were learning about AI, let's say earlier than 5 years ago, you'll be using libraries like Terrano. They were not Python libraries. If you are, Python is quite intuitive to learn. So they were not Python libraries, so they were not accessible. And then internet access. I talk about how internet has changed everything, the access, the leverage, the platform. It means that if the way it works in AI, if I don't know if anybody knows anything about GP3. If a big model is made open source today, just because I have access to the internet, just like people in America or in any other part of the world, I have access to the same knowledge, to the same tools, to the same open source libraries, to the same, just because the internet exists. And this is why AI and data science are spread. We have learning content. Most people started their AI career watching maybe Andrew Ng on Coursera, because I also have access to Coursera. You literally learn things from innovators of ideas right now. There are libraries that I use at work. There are libraries that I use at work that I talk to the people that actually invented them. People that are building that, we could chat on Twitter. Oh, guy, this is what I did. This is what I wrote about. It's what the internet does. And that is why there's so much fuss about data science, AI, and analytics, because I have a philosophy that it's not mystical, it's not something out of your reach. It's not, it's hard work, but it's hard work just like you put your time to any other thing. But it's not unreachable. The internet has broken it down. Like, there's literally nothing that you want to learn. In fact, even if you don't have money, sometimes if you get great at finding, free content, you will find what you need. And that is where this AI and data science explosion came from. People can implement faster. I can try, I can say, oh, want to see the effect of what this algorithm does. I mostly work in research. So, my day job is mostly, we want to see what this algorithm does, what kind of result did we get, these were our findings when we tried this model. So it's quite technical for what we are discussing here. But the internet has brought that down, and that's why, there's data science, AI, and there is so much noise about it, because there's so much data to analyze. Okay, please, if you have questions, if you have, let me know. Okay, so something interesting happened when I was putting together this slides. I would like to say the first thing is that data science and AI, they're already in your life. Okay, let me pause a bit. What do you know that it is AI that is doing that you come across with every day? Please answer the question. Like, is there a tool that you use that this is powered by AI and data science-ish stuff? So let me chill a bit and drink water and see if you know how AI and data science are already in your life. So I'm waiting for responses. Okay, I'll just wait. Are there tools that you use that is powered by AI? That this is AI in action? Let me see if you know that already. Okay, I'm waiting for responses. Social media. Okay, Yimeka says social media. How do you think AI is in social media, Yimeka? Okay, Yimeka, how do you think AI is in social media? You have asked social media, e-diagnosing. Okay, do you have a specific experience with e-diagnosing? I want to try to share something. I don't know if it will work well. Yes, how Facebook, IG, Twitter predicts content you would like to see. Great. This is from Yimika's perspective. So I'm waiting for others. Young Pharmacists Group. I know a Nigerian startup that uses this e-diagnosis. Do you know how they use it? Okay, the software you use in your community pharmacy, what does eHealth and QuickBook use? How do you think they incorporate AI? That this thing that it's doing, that it's AI. And I think there is something that, okay, I didn't put this on this slide, but I think I should give the difference between machine learning. Yes, Obia Emmanuel says you to predict videos you like to watch. Okay, so the difference between machine learning, they must have imputed some data into the algorithm. Sure. Okay. Let me wait a bit. Google, on Google Photo, Google groups pictures according to faces. Okay. I like the instances that I'm getting because they are actual things that we use in our daily life, that this is powered by AI. Because I think I should, I'll give some perspective on how difficult it is to train the systems and how it has truly, revolutionized how we use data. Okay, are there other instances where you know that this thing that is working is AI? Okay, Google Maps, cool. For detecting traffic, perfect. Okay, so there's an image on the screen. When I was making the slides for this, PowerPoint was auto suggesting designs. So that means that when I got this, I'm not that artistic in the sense that I'm terrible with colors and things like that. So it's not me that came up with these colors. It was AI that helped me. I just put it, I know that it has designer. Designer is powered by ML. It's a machine learning engine that has trained on millions of slides that other people have made. And then it suggested this. And I thought, this multicolor is fine. Let me try it. But this is designer in action. Let me see if I can do escape. And if it will suggest other things to me, if it works live or okay. Let me see if I prompt it, it's going to work. Okay. It's not working like I want. But I didn't come up with this slide. I chose a template. The inverter is off. Let me put on light. So I mostly chose a template and then it was auto suggesting. And that's one of the powers of AI. And yes, Amazon product selection for customers. Okay, thank you everyone. Thank you for for engaging. Let me make this bigger. Okay, so it's rolling. Thank you everyone for engaging and for sharing interesting things. So yeah, I said, how is data science? This thing is okay. So how is data science and AI? There's a typo here. Sorry. I had to recopy it to make the slides. Sorry, there's bad English somewhere there. Okay, so recommender systems. Yimika started with social media. Some of those recommendations, those things, it's not like anybody is tracking you specifically. No one is tracking you specifically. It's just AI working. I see people enjoying the topic modeling. It's NLP on Twitter when it puts similar topics together. Nobody is really sitting down per se. Of course, the training data, they probably sat down to train it, but that's one of the power of AI because we are many and it's delivering those results very fast. It's delivering the results very fast. It's suggesting your friends from school, the recommender engines, music. For music now, I see people doing battle of the brands. Oh, do I want to use Spotify? Apple Music is this, YouTube is this. And this is slow. Sorry. I shouldn't have used the live. Yeah, so recommender systems, I think, is one of the ones that are familiar. It's Netflix, this platform, they have serious engineering teams working on recommender system, machine learning to deliver the most similar content to you. what usually happens, the difference between systems that are powered by AI and machine learning and a typical system is that the way your Twitter works, if you're on Twitter, that it tries to group together different topics, your code will have to be rule-based. There were systems before AI became prominent, and systems like Google, the big people, they've been using AI for a very long time. They invested in it, they invested in the technology, they invested in the people that can do those things. But what usually happens before for recommender system, if you want to add code it, that's the opposite of machine learning. If you want to add code it, that means that if you have let's say 1,000 movies in your database, someone literally needs to sit down that if a user chooses Jumanji, then suggest this list of movies to them. You will now list it. You will list it one by one. But now that people have, people are getting 100 million videos per day, it's humanly impossible to sit through all that. And, it's humanly impossible to sit through that and be suggesting. And that's where machine learning algorithms, where they shine. What machine learning algorithms do is that they learn pattern in data for you. That means that I'm going to use an instance of, one of the ways I use machine learning. So that means that if I have a database, if I have let's say I have a database, a big place where I want my system to be able to recognize names of people, I want it to be able to recognize their age. What I'll do with machine learning, let's say I have 1 million, data points. What I will typically do, if I have a pre-trained model, I can transfer some of the things that I've learned. There's this thing called transfer learning. But what I'll typically do is that rather than label 1 million instances for name, I will pick a section. I'm going to pick a section of, let's say, maybe just maybe 1,000. 1,000, then I label it for those things that I want. Then I use a learning algorithm to learn that pattern. And the better I can learn it in context, that means that machine, what will I say? Machine is not as smart as humans. So learning in context is something you want to watch out for in designing systems like that. So you learn it in context that if I say Wurala Yewusi is a girl, and the next name is that, Amadou Musa is a farmer, the system that can recognize that Wurala Yewusi is, a girl, or, must be able to recognize names of people in other contexts. So even if you change, if your context is something is a farmer, depending on how you expose your initial learning model, it should still be able to figure it out. And that's what you work hard and optimize at. But like I said, the difference between an act coding system and a machine learning system is that, rather than, make decisions for people, because what happens on your YouTube is that there are different decisions that your video is making, is using maybe some context filtering. There are other people that have watched that particular video, they seem to be watching a lot of this, it aggregates and suggests to you. So when you reject, you help it to train that system to suit you. YouTube does not show the same thing to everyone, and that's why it's, companies that can optimize for that, they are the ones that are winning. Search. Google search has even there's something called BERT that has improved search. Before AI became more prominent, before some algorithms could work, what usually happens when you type something into search window is that it breaks the tokens down, and then it tries to find words with similar tokens. That means that if your text has data science, it's going to bring out web pages that has data inside, that has science inside. But AI has helped you to improve context. That means that if you are trying to type in something in a positive context, it tries to bring you results in positive context too. People hate this, but it's happening already. Targeted advertisements. Well, I'm not going to say that's exactly what they do, but I've heard a lot of people say, I spoke about this, and then I can see adverts related to that. I want to learn French, and then I can see adverts related to French. It's AI, it's text to speech, it's it's speech, a bit of speech to text, speech to speech. It's AI, it's unstructured data that is helping them to act like witches. And sometimes you're angry, but it's exactly what you need, and then you just click on it. Your digital assistant, Siri, Alexa, Google, they are not perfect, but they work. And sometimes they don't understand the accent. And well, you have that. So these are some of the instances. I like that people could figure out recommender systems, Amazon suggesting things to you. And then there are issues with recommender systems, like let's say somebody buys fan. Your recommender system, that works well, it should not be recommending other fans to you. You cannot buy 100 fans in a lifetime. It's just as smart as humans. AI can take a lot of mundane job out of your life, and you can do more. Okay, so in conclusion, I'll say that the world has evolved. And if you look at the best performing companies, the people making most of the money, they are data companies. They are the companies that can derive the best of insights from the data that they have access to. It's why they say that if you're not paying for the services, you're the product. By the virtue of using Facebook, literally have my life history, maybe for the past 10 years. Maybe if we even look at my data, we can pinpoint when, sorry, there's a typo here, sorry. Okay, maybe we can pinpoint some of maybe we can pinpoint the time that I was heartbroken. You have friends that have kids. Facebook has that data, and there is no way they will use that data to sell something to you. They will use that data in adverts. And it's their strength. And now they are consolidating data, sharing data with your Instagram. Google probably knows the kind of music that you like by the virtue of search. They are not going to say that's what they did, but you just say, oh, I like this type of song. How does this thing know that, oh, this is a kind of music that I like? It's one of the ways. So the data company, the people that can derive credible insights from data, they are the winners. They are at the forefront of making money. People in drug discovery, for people that can use AI to maybe iterate through a larger database than checking it one by one. They have the advantage of speed. For people that work in pharmaceutical industry, some of the reasons some products perform better than others is because they have data. They know where the pharmacies are. They know where not to worry about. They probably know where not to use a middleman. They know where to use middlemen. They know what to outsource. So the most successful companies, they are the data companies. Not just data companies that collect data, the people that actually use it. So I've used this instance before, in community pharmacy, you can do a bit of context analysis. What are the most common products that people seem to buy together? Will it increase your sales if you arrange them together? Do people actually care about brand name, or they just want to get better? I'm sure pharmacists do it. Sometimes some clients, you just, ask them to find that brand. If you include the services, does it improve your outcome? Those are some of the ways you can use data. And like I said, real analysis is mostly tool agnostic. There's much magic that you can do maybe with your Excel, to find pattern. Even things like maybe your farm technician, do you think that, if they work, I don't know how people do scheduling in pharmacy, but do you think that if they work 8 to 8 and they take a week off, can you have better productivity? For pharmacy, those are ways that you use data to optimize things. For some things, if we rearrange our shelf in this way, is there a particular salesperson that when the person's around, the person, may not have the best customer service, but the person can arrange shelf? Can you schedule arranging shelf to that person's shift? And, decisions like that. Okay. So the most successful companies, people that make the best of money right now, they are, they are data companies. How much of coding do you need to know? What are the basic programming language you need to know? Okay, so that's the conclusion. So I'll take questions. How much of coding do you need to know in order to be good in data science, machine learning, and what are the basic programming languages? This is a difficult question to answer because we learn at different pace. But the truth is that, as you explore, let's say you're following a structured course or something, there are assignments, do you know how to handle them well? Maybe that's a marker. But a lot, if you are into machine learning and AI, obviously, a lot. But they are learnable and the learning content is online. And they are not in one place. If you're trying to, learn, I see sometimes people try to talk to me. And like I say, I give pharmacists preference because I know that, in fact, I try to, anybody that reaches out, even though it's not everybody that will take it, I know sometimes what you need is a little information and then it changes what you need. So I try not to be, angry. Even when some people are quite overbearing, I try not to be, because sometimes if you have information, you can do so much more. So if you're trying to get into machine learning and AI, as you are exploring whatever learning platform you are learning, it's just that the truth is that what you need to become great at this is not in one place. Sometimes I see people just want to take one course. You can't do a lot with one course. You can't. But it's okay to start from there. And your learning cannot be casual. It's not you code today, you won't code tomorrow. If that's your plan, maybe a full career switch. And sometimes understanding the fundamentals is just to be able to describe your problems better. You can outsource. You can outsource your data analysis. So let's say you want to look at the pattern in your sales data in your pharmacy. You don't think you can do it. You want to outsource it to someone. Having an idea of the kind of insight that you can find from there, it will help you to specify your job description better. It will help you to recruit perfectly for that role. And it will help you to define what you're expecting from that engagement. So if you're learning casually and you're open to outsourcing, that's okay. It's not everybody that has to code. What are the basic tools that I learned to start up in data science and analytics field? The truth is that whatever you need is online. It depends on how great you are at searching things online. And personally, when people ask, I've studied quite a lot because it's a whole career change for me. So it's not like I can say that, oh, this is the specific course that I took and then I knew everything. I was taking courses from all angles. In fact, literally the year that I was in the middle of that switch, if I wasn't seeing patients, I was coding. It was that bad. I have to tell you the truth. So it's not casual. And for some people that are giving it a try, maybe you're doing 1 hour per week. 1 hour per week is small. That's why you don't know a lot yet. It's small. The time you're probably giving in is small because you're trying to learn basics of programming. You're trying to learn some statistics. You're trying to learn some maths. You're trying to learn maybe some of the algorithms that exist. So it's time intensive. It is. I have to tell you the truth. It's time intensive, but whatever you need is mostly online. Sometimes you pay for some courses, some are free. So your basic toolkit, I can say you get good at spreadsheets. I can see many people have an idea of SPSS and Excel. Demystify it first. Use it to understand the fundamentals, and you can make a lot of money doing Excel. You can make a lot of money. In fact, if you're considering tech is big, and there are roles that pharmacists are naturally suited for. You may need to find a couple of courses here and there. But, let me just share with you, pharmacists are already good product managers. Yes, many pharmacists are good marketers. You can run the sales team. There are pharmacists creative with maybe user design and interface. If you can sit down with it, you just sit down. Careers in tech, there are many of them that are non-coding. There are careers in technology that There are no-code tools that you can use. Some people are great with visualization. People pay a lot for good data visualization. You can start with visualizing with Excel. From there, you get better at maybe Power BI. You get good at presenting. It's a whole career path. And, personally, I understand the intricacies of being a pharmacist. You probably want more. That's why some people are here. They want to be able to afford things and things like that. So, there are skills that put you on a global scale. And like I said, the barrier to entry in tech, it's prove your expertise. Prove your expertise. If you are great at it, many times you get picked. Like now, I'm in a highly specialized field, but sincerely, it's not everybody that will be in AI research. So it's not everybody that will be in AI research, but there are many things you can do. And I think you should explore it because you don't have the barrier of, how to learn. You've done more difficult things in pharmacy school. The difference between machine learning and artificial intelligence, machine learning is a tool of artificial intelligence. It's one of those things you do in the scope of AI. Okay, do I have other questions? And then, for people trying to learn, like the person asking about how much of coding do you need? You can decide to go for a structured course, check Coursera. Some of them even have scholarships. You should apply Udacity, something, data science specialization. At least that way, I think it's not everybody that knows how to find things online. It's not necessarily bad. You may just need to pay for a structured course and then you follow it end to end and actually complete it. Okay, so do I have other questions? This is 121. I've been here since 12. That's a whole 1 hour and 22 minutes. That's a lot. Okay. Yes, so the people that make the best of decisions, they are the data people. If data is telling you are probably not earning enough, it's true. And it may not be your current workplace that will pay you that money. Okay, this is off record. Otega, how to find things online. What I'll say is that, how do I explain this well? How do I explain this well? Because most times you just keep clicking. Okay, I'm going to use this instance. You know that thing, let's say you're looking for the dosage of something, and then you search online. There'll be one, maybe probably something not detailed on Wikipedia, but somehow by experience, you know that Medscape usually have it, or Webscape, or I've forgotten the second of Medscape. I like Medscape. So it's just how you search, because I was saying your learning journey, if you're trying to learn alone, many people try to look for maybe a specific person, give me a syllabus. There's really nothing like that. And then you can look for other people's stories. People share their syllabus online. This is my learning process. By the time you combine learning from about 5 people, you will have a good feel of maybe this is what I need to be a good data scientist. And sometimes people share link to free resources. Many times just click and don't be ashamed. I think it's really I think my nephews are making noise. Okay, I think what usually happens to people is that they think it's a genius thing. It's not really a genius thing. It's really the thing of people that show up, people that are willing to give it a try. You failed it the first time. You probably took a course, maybe it failed, you try it again. That's usually what happens. Festus, in fact, my KPI at work has quite a number of mentoring. So I think most people should just follow me from afar and reach out to me with specific questions. Festus, I'm on LinkedIn and I'm on Twitter. I think I was tagged in the LinkedIn announcement. I can see Sunday. Sunday is from my class. How are you, Sunday? I hope it's the Sunday from my class in school. Okay. Hi, Sunday. Okay, so I hope you had a great time. Please, if you're trying to ask me questions, I try to answer questions. Just make it learning specific. I'm always happy to answer something like, oh, I was trying to write a Python string, something that happened. It's easy for me to say, oh, go check this out. But to be sincere, I get quite a lot of DM, it can be overwhelming. So, but the more specific your questions are, the more I'm willing to help. Where all I'm considering these courses, I have checked Coursera, this is the title they have. Udacity, this is the title they have. I'm considering either, it's easier for me to say, oh, check out Coursera's own, check out DataCamp's own, rather than teach me from the beginning. It's stressful for me because I think this is a pharmacy team and I should be able to tell you that. Okay. We've come to the end of this. I've been talking for the past 1 hour or more. Thank you for the invitation. I hope for people trying to get better at analytics, you give it a try. You can start with Excel. I'm serious. Your goal can be, I want to get very good at how Excel works. There's so much in Excel. And you can start from spreadsheets. If Excel is paid, you can try from G Sheets, how to run this analysis. It's there. For most things, you can, it's there. It's usually just there. It's if you give it a try. Okay, thank you, everyone. Thank you for listening. I'll stop sharing my screen.
Okay, thank you very much for this wonderful session. Actually, thank you very much. We have learned a lot today in data science and analytics, actually. Thank you very much. And thank you everyone that joined this webinar. It's really, really encouraging to see you guys here. Thank you very much. I will leave the floor to the national chairperson. If there's any announcements or anything that she wants us to say. So I will leave the floor to Emeka Oguns if there's any announcement for the zone. Thank you very much. And remember, this webinar is actually in line with the plan of the national chairman, who is, she's Emeka Oguns. So it's part of her plan to have zone-specific projects. So one of her projects that she has for the zone is this webinar also, and going to have some programs as the year goes on. So with Professional Development Committee and we try to put this webinar in place in line with our own plan. So we are expecting to see a lot of programs in the zone. And this webinar is only not for Northwest. So other zones in the country will also have similar webinar based on their own topic of interest. So I will leave the floor to the national chairman if there's any announcement for the zone. Thank you very much. The floor is yours, ma'am.
Thank you very much, Nora. I think you've said basically any other thing that I would have loved to say. And again, this was a really great session. Thank you for pulling it off with the Professional Development Committee. And also thank you very much, Werola, for making our time to join us. I think there's a replay on YouTube for people who didn't join us from the beginning. So you can actually go through the replay to find out what you missed. And hopefully we can start seeing more pharmacists playing in the data science space going forward. I think that's all from my end. And see you guys soon on other programs that we have lined up. Thank you very, very much.
Thank you so much. It's nice that you are here today, actually. Thank you very much. The National Secretary General, anything?
None at all.
Okay, all right. So we are coming to the end of the webinar, actually, and thank you for the participation, and see you in our programs that we have for the zone. All right. Thank you, EA Sadiq, actually. Thank you for the participation.